The next two video lessons I do will look a little bit different than the sheets that you guys have. However, just follow along and you should be fine. I do have most of the same stuff here. This first one is the first example, and it didn't come out too well. However, we want to graph f of x equals 2 of the x. And the way we're going to do that is first by completing the table. Now, your table looks a little bit nicer than mine right now. That's okay. You can still follow along with what I'm going to do here. They did plug a -3 in for you already. When they plug a -3 in, they got 1/8. Now you plug a -2 in. 2 to the -2nd power is 1/4. And then 2 to the -1st is 1/2. 2 to the 0 is 1. 2 to the 1st is 2. 2 squared is 4. 2 cubed is 8. If you wanted to, you could type the 2 to the x in your y equals and do your second graph button, which will give you a table, and you can plug in your values. From there, what I want to do is sketch the graph, and again, you guys already have a graph drawn for you with the axes already. Give me a second and I'll draw mine in. They go up by ones, but they only label every 2. So they label it 2, 4, 6, 8. And they label it as 2, 4, and -2, -4. From there, plot the points the best you can. I'm going to go backwards, so 3, 8 is one of them. 2, 4 is another. 1, 2. 0, 1. -1, 1/2. And it slowly goes towards 0. So it would look something like that. So we did this part B, which says plot the points and connect the points with a smooth curve. Do not hit the x-axis, please. It will get closer and closer to, but never actually hit it. Question 1a. It says, what happens to f of x as x increases without bound? And what happens to f of x as x decreases without bound? Well, the first 1a, what it's asking, as x is increasing, so as my x's are getting bigger and bigger and bigger, I'm asking what is happening to f of x, or what is happening to my graph. Looking at this graph, we can see that it's increasing. So we're going to say f of x will increase as x increases, and f of x will, let's go back and see what happens as x decreases without bound. Well, as I choose smaller and smaller x values, this line is getting closer and closer and closer to the x-axis, but remember, it'll never touch it. So and f of x will approach 0 as x decreases. Wants to know, does the graph intersect the x-axis? Explain how you know. Well, the answer, I've already said it a couple times, is going to be no. Okay? The real reason is because you can't ever get a y value of 0 as an answer to y equals 2 to the x. Y can't equal 0 when you have an exponential graph. And finally, 1c, what is the domain and the range of the function? Well, domain are x values. This thing is going to go left and right forever. Since it's going left and right forever, the domain is all real numbers. The range are the y's, up and down. It is going to go up forever, but it's only going to go down until it hits to the 0. It's never actually going to hit 0, so it's always going to be above the 0. So the way we say that is going to be the domain is all real numbers. Remember, we can abbreviate it as R with a line through it. And the range is that y has to be greater than 0. It can't equal 0, and it's not going to be less than 0. Let's move on and see what else we have here. We're going to skip example 2. The reason we're skipping example 2 is I'm going to have you guys go back and try that as you're due now when I get done with this video. So let's go to example 3. Please look at your example 3. There are pictures on yours that are not on mine. And the picture on the left-hand side shows exponential growth. That graph's going up forever. And the other one shows exponential decay. It's going down and trying to hit 0. 3a says, describe the end behavior of an exponential growth function. Well, the end behavior of an exponential growth function, if you look at your picture, is going up forever. So it will increase without bound. Without bound means it goes on forever. Without W line O. The end behavior of an exponential decay, that's your picture on the right-hand side, it's not going down forever. It's getting closer and closer to 0. So the end behavior of an exponential decay function will approach 0. The point 1b is always on the graph. If you look at both of those graphs, that point 1b is on both of them. Well, it's going to be on all of them, and the reason is because any value to the first power, that's what the x stands for, the power, when you plug in, will always be itself. The point 0,1, if you look at both of those, will always be on the graph, and the reason is because any value, remember the x is the power, so any value to the 0 power always equals 1. Part 3e, are f of x equals 3 to the x and 5 to the x exponential functions of growth or decay? And since they have the same end behavior, how do you think their graphs differ? Explain your reasoning. Both of them are growth. The reason we know they're growth is because the bases 3 and 5 are bigger than 1. So I'm going to put b is greater than 1. Although they have the same end behavior, the function, did they call it an f or a g? G of x equals 5 to the x will increase faster. And the reason is because it has a larger base. F, 3f. This time we have f of x is 1/3 to the x power, and g of x is 1/5 to the x power. Both of these functions are decay, so are decay. And the reason is because the b value is less than 1. It's a fraction. Although they have the same end behavior, the function 1/5 to the x value will decrease faster. Because it has a smaller, 1/5 is smaller. It has a smaller base. See what else we have here? Nope, at this point I'd like you to try example 2 in the notes, and we will work on the rest of the packet tomorrow in class.